Now, today lecture number 7. Bismillah Rahman Rahim. So, last time we have discussed ionization, right? So, first factor which I have discussed, nuclear charge. Now, first question about the nuclear charge, right? You know that nuclear charge is the number of proton, right? Yesterday, we have discussed about the nuclear charge. So, nuclear charge means proton. Point number 1, nuclear charge means proton. Point number 2, across the period, proton number increases. Across the period, proton number increases. So nuclear attraction increases. Shell remains same. Across the period, shell remains same. Shielding remains same. So because of the increased nuclear power, nuclear attraction, more energy is required to remove the electron. That's why ionization energy increases. Across the period, ionization energy increases. Ionization energy means to remove electron, to remove one electron from gaseous atom to form gaseous plus one ion. So first question about ionization energy. It is from 2016. 2016 summer paper 21. 21. State and explain the general trend in the first ionization energies across the third period. State and explain the trend across the period as our first factor on which ionization energy depend is number of proton, nuclear charge. So this question is for 2 marks. State and explain the general trend. If you have some exception, ignore it. Ignore the exception because examiner asks about the general trend. So first mark. Across the period, means period 3. Across the period means period 3. Ionization energy increases. Ionization energy increases. Why increases? As proton number increases. As proton number increases. Across the period, proton number increases. Nuclear attraction increases. Nuclear attraction increases. Nuclear attraction increases. Same shell, same shielding. These are the maximum point. Maximum point for 2 marks or 3 marks. Same shell, same shielding. Hence, more energy is required to overcome this attraction to remove an electron. Hence, more energy is required. More energy is required to overcome This attraction to remove an electron, to remove an electron, to remove an electron. This is the fourth point. This is the fourth point for 2 marks, right? For 2 marks. So these are the factors on which, this is the factor on which lattice energy, ionization energy depends. Now question number 2 for 3 marks. Now question number 2 for 3 marks. Compare ionization energy between lithium and carbon. This is for 3 marks. Now, can anyone tell me lithium and carbon? Can anyone tell me their period number or group number? Yes.
Carbon,
Lithium and carbon, right? You know that
lithium,
lithium is
then
3,
period 2. Sorry,
period
period.
period 2, and the group.
Carbon, lithium is in group 1 and carbon is in group 4.
So it means they are in the same, they are in the same period.
Yeah.
So
However,
this, so
carbon will
this,
have
so
more
this,
ionization energy.
exactly. So which one has more proton?
More protons?
Yes, lithium or carbon?
Carbon.
Carbon has more proton. Which one has more nuclear attraction?
Which one has higher nuclear attraction? Also carbon, right?
Carbon. So which one has, say, which one require more energy to remove an electron?
Carbon.
Carbon. So these are the 3 points for 3 marks, right? So I am writing carbon has more proton. Carbon has more proton, more nuclear attraction, more nuclear attraction, more nuclear attraction than lithium. Than lithium. This is our first point. Now, second point, either they have same shell or different shell. Yes. You know that their period number is same. So shell remains same. Shell remains same. Shielding remains same. Shielding remains same. As you told me that period number is 2. So shell number is 2 for both of them. So shell remains same, shielding remains same. So shell factor, size factor is neglected because same shell, same shielding. Now third point is more energy is required by calcium to overcome This attraction to remove an electron, to remove an electron. So 3 marks, 3 point. 3 marks for 3 point. Now we have discussed first nuclear charge. Now second factor on which ionization energy depends is nuclear distance. Hamza, do you have any question
Not so
regarding
far.
nuclear attraction? Yes?
No, I'm okay. I have no questions.
Okay, alhamdulillah. Next is nuclear distance. Nuclear distance. First point,
Sorry, sir, I disconnected.
Guys,
Sir, I can't hear you.
now
Yes, now I can.
you can hear, right?
Yes, now I can.
Okay, I am asking a question,
I can't see
right?
your screen, sir.
Okay, I am sharing. Just a minute. Yes. Now I was asking that down the group shell increases or shell remains same? Yes. Can anyone tell me down the group shell increases or remains same?
It increases.
Shell increases. Very good. So down the group, shell increases. So shielding increases. Shielding of inner electron also increases. Shielding means when inner electrons cover nucleus. So attraction of nucleus to the valence shell decreases. This property is called shielding. So down the group shell increases. As the shell increases, inner electron increases, shielding also increases. Now can you tell me, as the shell increases, what about the nuclear attraction? Either it is increases or decreases.
Nuclear attraction will also increase, right?
Now listen again. If the nuclear distance increases,
Does it
nuclear
decrease?
yes, decreases. So as the nuclear distance increases, it means the distance between the nucleus and the valence shell. So nuclear attraction decreases. If the nuclear distance increases and nuclear attraction decreases, less energy is required to remove the electron. Hence, ionization energy decreases. As you all know that ionization energy means power or energy required to remove an electron from valence shell. Are you all getting my point or not, Isa?
Yes, sir.
Yes.
Yes, sir,
Alhamdulillah.
I got your point.
Alhamdulillah. So as size increases, nuclear attraction decreases. Nuclear attraction decreases. Nuclear attraction decreases. Ionization energy also decreases. Also decreases. Now, a question. Compare ionization energy between lithium and potassium. So here we have lithium. Lithium is 3 and potassium is 19. So 2 comma 1, 2, 8, 8, 1. So can you tell me how many valence electron are there in both? Yes. Can anyone tell me number of valence electron in both of them?
1, right?
1. So it means group number is 1. It means group number is 1, group is same. So now can anyone tell me the number of shell in lithium? Yes, can anyone tell me the number of shell or period number of lithium?
Two shells.
2. And
Yeah.
what about the potassium?
Oh, that would be 4.
So
4.
it means shell, it means shell is changed. It means
Right.
shell is changed. So they
Yeah.
have same valence electron, but shell is changed. Always remember, when period is changed, give the answer according to the nuclear distance. So write first point. First point, lithium. Lithium has valence electron in second shell, while potassium 19 has in fourth shell. So which one has greater nuclear distance? Yes. Yes, which one has greater nuclear distance?
Potassium.
Potassium. So lithium has less nuclear distance. Lithium has less nuclear distance, more nuclear attraction, more ionizing energy, more ionization energy than potassium. So one point is missing, that is shielding. That is shielding. So K19 has more shell, more shielding of inner electrons. Inner electrons. Yes, any question?
No, sir.
Okay,
No.
Alhamdulillah, no question. Now you can see both structure, right? This is the first shell. This is the second shell. This is lithium. This is second shell. Here we have, sorry. This is third shell. Here we have fourth shell. Fourth shell. So here we have 1, 2, 3. Very less nuclear distance. Here we have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and 1 electron. So here this is the nuclear distance. Here we have nuclear distance. So you can see that this is lithium, this is potassium. So potassium has more nuclear distance, and hence less ionization energy. Do you have any question regarding nuclear charge and nuclear distance? Yes. Any question regarding
No,
nuclear charge or nuclear distance? Yes, beta. Do you have any question?
no, sir.
Okay. Zania, do you have?
No, sir.
Okay. Now the third factor. I am starting third factor, right? And the third factor is shielding. Shielding effect of inner electrons. Inner electrons. Inner electrons. Now look at the structure of an atom. This is second shell, third shell, and then fourth shell. Here we have 2 electrons, then 8 electron, then 8 electrons, then 2 electron. Can anyone identify the element? Yes. Can you identify the element? Oh my God. Can anyone identify the element by looking the number of electron? There is no
Yes,
charge.
sir.
So number of electron is equal to number of proton. You can easily identify the element. Yes.
2, 10, that's going to be 18, and then 20, so it's in
20.
20.
Mhm.
That would be calcium.
Calcium, exactly. So you can see that these two are valence electron. These two are valence electron. Valence electron. While these all electrons, these all electrons are called inner electrons other than valence electron. These are called inner electrons. Inner electron. So electron between nucleus and valence shell are called inner electrons. So write the first point. What are inner electrons? So inner electrons are electrons between nucleus and valence shell. Nucleus and valence shell. Now, can you even tell me inner electrons increases the nuclear attraction or decreases the nuclear attraction? Yes. You know that nucleus, valence electrons are attracted by nucleus. We all know that valence electrons are attracted by nucleus. And ionization energy means removal of valence electron. Now, my question is that what is the role of inner electrons? Either they increase the electronic nuclear attraction or decreases. Yes, but I need your quick response.
Decrease.
Yes, exactly. Attraction decreases because nucleus is shield it. Nucleus is covered by inner electrons. So the affection between the nucleus and valence electron is decreased because of inner electron. So the next point is attraction between nucleus and valence electron is reduced by inner electron. This effect is called shielding effect of inner electron. This reduction of nuclear attraction due to inner electron is called shielding effect of inner electron. Are you getting my point?
Yes, sir.
So decrease of nuclear attraction due to inner electron decrease of nuclear attraction due to inner electron is called shielding effect. Shielding effect of inner electrons. So what is the role of shielding? It increases or decreases the ionization energy? Yes,
Decreases.
exactly. As a result of shielding, as a result of shielding or shielding effect of inner electron, ionization energy decreases. Ionization energy decreases. Ionization energy decreases. Now, next question. Compare shielding effect of, compare shielding effect of, compare shielding effect of lithium and potassium. Compare shielding effect of lithium and potassium. Here we have lithium and potassium. Here we have lithium and potassium. So which one has, can you tell me inner electron of lithium? Yes. Can you tell me inner electron of lithium?
Sir, 2.
2. So first point, lithium has 2 inner electron. Lithium has 2 inner electron. And what about the potassium?
18.
18 inner electrons, correct. 18 inner electrons. Point number 2. Point number 2. So can anyone tell me which one has more shielding?
Potassium.
So
Potassium.
potassium. So potassium has more shell, more shielding. Potassium has more shell, more shielding, less nuclear attraction, less nuclear attraction, less ionization energy, less ionization energy, less ionization energy. Now look at the summary of ionization energy. Remember one thing, that one factor is still left, which is spin pair repulsion. So summary. Now let's suppose this is periodic table, and this indicates across the period, and this one indicates down the group. So this is across the period, and the second one is down the group. Down the group. So as I told you, I have some magical trick, right? So I name this magical trick as DI. DI means doctor instruction. So memorize this DI. So across the period, yes, can you tell me proton number increases or decreases?
It increases.
Increases. Point number 2, ionization energy. Yes,
It increases.
also increases. Now nuclear attraction
Increases. Sorry,
increases.
decreases.
Nuclear attraction increases, right?
Wait, when you say nuclear attraction, do you refer to like to the forces of attraction, or?
Both are same thing, because this attraction is due to the nucleus. So you
Okay.
can also use the word force of attraction. So generally this force of attraction is generated by the nucleus. So you can say that force of attraction generated by the nucleus, or nuclear attraction, anything else, right? Anything you can use. So nuclear attraction. So it also increases. So we have discussed 3. So as proton number increases, nuclear attraction increases, ionization energy increases. Now what about the shielding and shell? Yes. Shielding increases, shell increases, yes. Shell across the period, shell increases or decreases?
Sir, it remains same, doesn't it?
Remains same, very good. So remains same. And what about the shielding?
It
Yes,
will also remain the same.
both remain the same, correct. Shielding remains the same. So next is down the group. Now down the group, yes, down the group. Tell me about the shell. Shell increases or decreases?
Increases.
Increases. And
Increases.
what about increases? And what about the shielding?
Increases.
Increases. Very good. Very, very good. Both increases. So this is increasing, increasing. And what about the nuclear attraction? Yes. What
It
about the
decreases.
nuclear attraction?
Decreases.
Nuclear attraction decreases. Nuclear attraction decreases. And what about the ionization energy?
It will also decrease.
Decrease.
Decreases. This is a small key to learn the factors on which lattice energy depend. Now, another DI. DI means doctor instruction, magical trick. You have to memorize this BB Ammi NOPS. BB do not say NOPS to Ammi. So BB Ammi NOPS. You have to memorize this sentence. BB Ammi NOPS. This is DI. BB Ammi NOPS. BB Ammi NOPS. B means beryllium and this B means boron. A for aluminium, M for magnesium. Next is, this is nitrogen. This is oxygen. Nitrogen and oxygen. This is nitrogen. And this one is oxygen. And the last one is phosphorus. Phosphorus and sulfur. So these are exception. Beryllium boron is exception. Aluminium magnesium is exception. Nitrogen and oxygen. Similarly, phosphorus and sulfur. Are you getting my point? What is BB aminops?
Yes, sir.
You can easily memorize exemption, right? So these are all exemptions.
Sir, I have a
So
question.
question, yes,
Sir, when you compare potassium and lithium,
yes,
potassium had less ionization energy due to its shielding because it had more shielding, but it also had more protons. So doesn't more protons mean more ionization energy?
yes. Now look at my statement. Now look at my statement during the first heading nuclear charge. So I told you across the period proton number increases, and
Yes.
so always consider proton number across the period. So always consider proton number increases across the period. Do not say down the group proton number increases. Yes, I know proton number also increases, but it is not the dominating factor. Dominating factor is shell. So down the group shell increases. Do not say proton number increases. Across the period, proton number increases. Down the group, shell increases. Do not say down the group proton number also increases. No, no, no. Because down the group, dominating factor is shell. Across the period, dominating factor is number of proton. Are you getting my point or not?
Yes, sir, I got it.
Alhamdulillah. Now write the question. Compare ionization energy of beryllium and boron. Boron is 5, beryllium is 4. Yes. Can anyone predict which one has more ionization energy? Now I need simply prediction. Yes. Yes. Can anyone predict? As we have discussed three factors, can anyone predict which one has more ionization energy?
Beryllium.
Why beryllium? Boron has more proton. So prediction would be that boron has more ionization energy than beryllium. Your prediction is wrong. Can you
But sir,
justify your statement? Can you justify your statement? Why boron has more ionization energy? Yes. Please don't hesitate. Please give the answer. Why beryllium has more ionization energy?
I think I didn't count the protons right, so I was under the impression that beryllium had like less shells, so therefore it would have more ionization energy.
No, no. Both beryllium and boron has same shell. You can look at your periodic table and
Okay.
notice that both have same shell. Isa, can you check it out?
Yes.
So shell is same. So both are across the period. So you know that across the period proton number increases. So prediction is ionization energy of boron should be greater than ionization energy of beryllium. It is our prediction. Why? Because of more proton. Are you getting my point or not?
Yes.
Now, this is exemption. This is exception. That's why it is wrong. This is exception. That's why it is wrong. I told you that memorize BB aminops. Only these four BB aminops. These four are exception, right? So ionization energy of boron is greater than ionization energy of beryllium. This is wrong. Why? Now look at the answer. Beryllium is 4, 1s2, 2s2. Similarly, boron is 5, 1s2, 2s2, 2p1. Now, can anyone tell me the inner electron of beryllium? Yes, can anyone tell me inner electron of beryllium?
2.
2. Inner electron 2. And what about the boron?
4.
4. So which one has more inner electron?
Boron.
Yes, boron. Boron has more inner electron. Which one has more shielding?
Boron.
So which one has less ionization energy?
Boron.
Boron. So that's why
Boron.
this prediction is wrong. Are you getting my point or not?
Yes.
Yes, Mohammed and you. Are you getting my point or not?
Yes.
Zaina. Zaina. Yes, your name is Zaina. Zaina Umar.
Um,
Am I
it's
right?
Zainab, but you can say that.
Okay, okay. Zaina. I'm sorry. Zaina. Uh, so write the statement, right? So valence electron of beryllium and boron are in 2s and 2p respectively. So valence electron of beryllium and boron are in 2s and 2p respectively. So both have, so beryllium has in 2s and 2p, boron has in 2p. So which is farther away from the nucleus? Yes, before 1s we have nucleus. Before 1s we have nucleus.
Boron.
So boron. So 2p is farther away from nucleus than 2s. 2p is farther away from nucleus than 2s. So which one has more shielding? Yes, which one has more shielding?
Boron in it.
Boron. Very good. So boron has more inner electron. Boron has more inner electrons than beryllium, hence more shielding. More shielding effect. That's why ionization energy of boron is less than ionization energy of beryllium. More shielding, more ionization energy. Am I right? More shielding, more ionization energy. Am I right?
No.
No.
So more shielding, less ionization energy.
Yes.
Less ionization energy. So more shielding, less ionization energy. Now question number 2, Ammi. This is BB. Now I am discussing Ammi. Now question number 2 is compare ionization energy of aluminum and magnesium. Aluminum, which is 13, magnesium, which is 12. So can anyone predict which one has more ionization energy? Aluminum or magnesium?
So the prediction will be aluminum.
Aluminum, very good. Aluminum, and because aluminum has more proton, both are in the same period. So across the period, proton number increases. But we know that this is exception. So prediction is would be wrong. Now look at the electronic configuration of aluminum and magnesium. So first, electronic configuration of magnesium. Magnesium is 12, aluminum is 13. So magnesium has 1s2, 2s2, 2p6, 3s2. Similarly, aluminum 1s2, 2s2, 2p6, 3s2, 3p1. So these are inner electrons. These are inner electrons. So can you tell me the inner electrons of magnesium?
10,
10. And what about the aluminum?
12.
12. So valence electron of magnesium and aluminum are in 3s and 3p respectively. Valence electron of magnesium and aluminum are in 3s and 3p respectively. You can see that valence electron is in third shell, 3s, valence electron is in 3p. So valence electron of magnesium are 3s and 3p respectively. So which is further away? 2p, 3p or 3s? Yes,
3p.
3p. 3p is farther away from nucleus than 3s. Now next, which one has more electron, inner electron?
Aluminium.
Aluminium, very good. Aluminium has more inner electron than magnesium, hence more shielding effect. So what would be your statement right now? Which one has less ionization energy and which one has more ionization energy? Yes.
Aluminium has more shells, so therefore more shielding and less ionization energy. And that's why magnesium has more than aluminium.
So ionization energy of magnesium is greater, right? Either they, uh, you know that magnesium has 12 protons, so less proton than aluminum, but due to more inner electrons, and you know that valence electron is in 3s, right, and less shielding in it. So due to less shielding, more attraction. More attraction means more ionization energy. Now, do you have any question regarding BB and ME?
No, sir.
Now, write the DI, summary and DI. Now, write summary and DI. SUMMARY. Summary, DI means magical trick, magical learning technique. So, here we have boron, and beryllium. Here we have aluminum, here we have magnesium. This is group 2. Can anyone tell me which one has more energy, beryllium or boron? Yes,
So beryllium.
beryllium. So it means you know that it is group 2 and this is group 13. Group 13. So which one has, according to prediction, group 13 should have more ionization energy than group 2. But actually, because we have exception, so group 13 has less ionization energy than group 2. Always remember, examiner ask any element, examiner ask any comparison between group 13 and 2. You always memorize that group 13 has less ionization energy than group 2. Peter, do you have any question?
No, sir.
Okay. Zaina, do you have any question
No, sir.
regard? Do you have any question regarding BB Ammi?
Not at the moment.
Okay, Alhamdulillah, Alhamdulillah. So we have discussed ionization energy and the factors. We have discussed all factors, and after these factors, we are discussing exception. Very easy way to memorize exception. BB Ammi NOPS. PB beryllium boron, Ammi aluminum magnesium. There is no literal meaning of I. We cannot make Ammi without I. So I is because to make Ammi. So there is no meaning of I. So BB beryllium boron exception. Ammi aluminum magnesium exception. Now nitrogen and oxygen and phosphorus and sulfur. Next heading is spin, pair, repulsion. Spin, pair, repulsion. Spin, pair, repulsion. Now for this question, compare ionization energy of nitrogen and oxygen NOx. Nitrogen 7, oxygen 8. Now can you give prediction? Yes, both are in the same period. Can anyone predict which one has high ionization energy?
Oxygen.
Oxygen, right? So prediction is that ionization energy of oxygen because oxygen has more proton. So ionization energy of oxygen is greater than ionization energy of nitrogen. This is our prediction, and the reason is oxygen has more proton than nitrogen. But we all know that we have BB aminops exception, so this would be wrong. So now electronic configuration of nitrogen, electronic configuration of oxygen. Nitrogen is 1s2, 2s2, 3p3. While oxygen is 1s2, 2s2, 2p4. Now you can see that both have valence electron in p orbital. So we know that p has three orbital, px, py, and pz. Now we have to fill these three electrons. So 1, 2, 3. So 3 electrons are filled. Now for oxygen, 1, 2, 3, and 4. Now can you tell me how many unpaired electrons and how many paired electrons are there in both? Can you tell me how many unpaired electron or paired electron? Yes, how many paired electron?
For nitrogen, there are none.
None, 0. And for oxygen,
1 pair. So 2
1 pair,
electrons.
2 electrons. So my question is that which box has more repulsion? Which box? Nitrogen box or oxygen box? Which box has more repulsion of electron and why? Yes,
So I think
you
oxygen.
have nitrogen box singly filled. Here you have oxygen box where here you have 2 paired and 2 unpaired. So which one has more repulsion? Yes, Isa, can you repeat your answer?
So I think nitrogen.
Why nitrogen? Nitrogen.
Yeah, I think
Why?
so.
Why?
Because there are 3 electrons over there, so I think
But
so.
in oxygen you have 4 electrons.
Yeah, but 2 of them are already paired.
Where you have paired electron? All are unpaired. In nitrogen,
No, I'm saying in oxygen they are paired.
in oxygen. Now look at, right? You know that oxygen has electron has negative charge, right? So can you tell me same negative charge attract each other or repel each other?
Repel.
So if they already repel each other, so it is quite easy to remove both of them because they already repel each other. Yes, what is your opinion right now, Isa?
Yeah.
What is your
Yes.
opinion right now? So oxygen has one paired electron. Paired electron repel each other. No, they have negative charge, so they already repel each other. So quite easy to remove one electron. Ionization energy means remove one electron. Are you getting my point or not?
Yes, sir. I got it.
Alhamdulillah. What about Zaina? What is your opinion? Which one has more repulsion?
I think nitrogen, but I don't really understand why.
You told me nitrogen has more repulsion, right? Now Zaina, listen. Now Zaina, listen. In each box you have single electrons, right? Single
Yes,
electron. But in oxygen you have paired electron,
which has which
which
repulse each other.
which repel each other. So it is quite easy to remove both of them because they already repel.
Okay.
If you want to separate two enemies, right? So which one is more difficult, to separate two enemies or to separate two friends? Yes,
Mm-hmm.
enemies. So they repel each other. So it's quite easy to remove one electron from oxygen. This is called spin pair repulsion.
Okay.
This direction is called spin. We have discussed in early classes. So this is spin, upward arrow. Upward is anti-clockwise. Anti-clockwise spin. And downward arrow means clockwise spin. Spin means movement of electron. We all know that electrons move. Movement of electron is called spin. So electron moves in two ways, either clockwise or anti-clockwise. If two electrons in a box element observe more repulsion of electron, so quite easy to remove this electron. This effect is called spin pair repulsion. Isa, are you getting my point? Zaina, are you getting my point or not?
Yes.
Yes, sir, I got it.
Okay, alhamdulillah, alhamdulillah, alhamdulillah. Now, write the answer. Oxygen has two unpaired and one paired electron, while nitrogen has three unpaired electrons. Next point. Paired electrons repel each other known as spin pair repulsion. Hence, ionization energy of oxygen 8 is less than ionization energy of nitrogen. Yes. Do you have any question regarding spin pair repulsion?
No, sir.
Yes, Anna.
No.
Alhamdulillah. Now, next question. Next question. Compare ionization energy compare ionization energy of phosphorus, NOx means phosphorus and sulfur. Ionization energy of phosphorus and sulfur 16. Now I need prediction. Which one has more? Yes, they have same period. They have same shell. Yes,
Sulfur.
sulfur. Ionization energy of sulfur is greater than, should be greater than, because of the more proton number. This prediction is wrong. So first of all, write the electronic configuration of here we have phosphorus 15, sulfur 16. 1:2, 2:2. 2p6, 3s2, 3p3. So sulfur 16, 1s2, 2s2, 2p6, 3s2, 3p4, 3p4. So same effect. So which one has two unpaired? Yes. Yes, which one has two unpaired?
Sulfur.
Sulfur. So sulfur has two unpaired and one paired. While phosphorus, yes, phosphorus, three
Three.
unpaired. So paired electron repel each other, known as spin pair repulsion. So ionization energy of phosphorus is less than ionization energy of sulfur. Any question?
No.
Okay. This is all about the ionization energy. So always remember there are, what is ionization energy? Ionization energy is the amount of energy required to remove 1 mole of electron from gaseous atom to form gaseous plus 1 ion. This is ionization energy. Point number 2, you have to memorize ionization energy is always endothermic. Energy required, it is always endothermic. Either first, either second, either third, either fourth. Then we discuss factors on which ionization energy depends. There are 4 factors. Number 1, nuclear charge. Across the period, nuclear charge increases, nuclear attraction increases, ionization energy increases. Second factor is nuclear distance. Down the group, shell increases, shielding increases, ionization energy decreases, nuclear attraction decreases. Factor number 3, shielding effect. Down the group, shielding inner electron increases, shielding of inner electron increases, nucleus is being shielded by the inner electron, hence nuclear attraction to the valence electron decreases, ionization energy decreases. So as the shielding increases, as the shell increases, ionization energy decreases. Last factor is spin pair repulsion. So as electrons paired in any orbital, their repulsion, they repel more, so they have less ionization energy. Do you have any question? Any question about ionization energy or factors on which ionization energy depends? Yes, do you have any question?
No, sir.
Okay. Zaina? Zaina, any question?
No, sir.
Now, the chapter is nearly ended, but remember magical graph. Now, make the heading magical graph and make the subheading successive ionization energy. Successive ionization energy. Now, my question is that, can anyone tell me how many electrons are there in F9? Can anyone tell me number of electron in it?
9.
9. So fluorine has 9
9.
electrons. 9 electrons. Very good. So it means it has 9 ionization energy. So it has 9 ionization energies. Point number 2. Point number 2. Electronic configuration is 2,7. Electronic configuration is 2,7. So can anyone tell me from where first electron is removed? Either from 7 or either from 2. Or we can say that either from valence electron or either from inner electron. Yes. Can anyone
Valence,
tell me? Yes.
valence electron.
Valence electron. So electrons are removed from valence shell. Electrons are removed from valence shell. Electrons are removed from valence shell. So next point, graph is plotted. Graph is plotted between ionization energy or log ionization energy or sometime natural log ionization energy and number of electron removed. So graph is plotted between ionization energy and electron removed. So inshallah, the graph we'll discuss in the next class. Do you have any question regarding ionization energy?
No, sir.
No.
Alhamdulillah.
Okay. Zaina, inshallah, after the completion of the first chapter, I will provide the whole PDF of this chapter, right?
Okay, thank you.
Okay. So inshallah, in the next class we will discuss. Okay, do you have any question? No?
No, sir.
Okay, beta. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.